Okay, good morning, everyone. Let's get started here. Today is Wednesday, so today we're going to discuss the first exam. We're going to do a little bit of 3.5 called completing the square, and then we're going to get into quadratic functions and their graphs. The material we cover today, okay, this will not be on exam. Okay, it's not on exam one. I just emailed everyone this morning. Just about, I don't know, 30 minutes ago, I emailed everyone a review for the exam. And it looks like this. Here's what it looks like. Exam 1414 exam one review, spring 2022. And it's just a big mixture of different types of problems. Let's see here, hold on. Yeah, and then the solutions to this review can be found where the homework videos, solution videos are. There's actually a video of me working through this review, with the exception of number 17. On the video I don't do number 17. Okay, so I'm hoping you can figure this one out. If you can't, you can come to me in my office hours or something. Text me or call me if you have trouble with number 17. Let's see what else. Our exam, of course, is Monday. All right. I've made some changes to the homework due dates. 3.5 is due this Sunday. If you have any trouble with 3.5 homework, refer to the homework solution video, because I go through the way it's done. The computer does like they give you a bunch of graphs and they ask you to match the function to the graph and things like that. So if you're having trouble with that, just watch my video. And then homework 4.3 is now pushed back all the way to the 27th, because we have to come next week on the 20th and take the test, right? So there won't be any new material. And then the 22nd, we will be doing 4.3, so then it won't be due until the next time we meet. So that's where we are. Any questions up to this point? I'm going to talk about the exam. So, okay. I was trying to wait and let everybody get here. So let's talk about the exam. What I've done is I pretty much have like copied and pasted the exam policy that I have in the syllabus. So that's what you're seeing here, with the exception of what's in red. What's in red, I've added to this. So this is our first test, so I really want to make sure you understand how this is going to work. You're going to come into the Zoom session on Monday. When class starts, I'm going to email everybody the test in Canvas. So you'll be on your computer and you'll get the exam. You'll see it on your screen. If you have a printer, you print it, okay? If you don't have a printer, you're going to have to hand write each problem, okay? It sucks, but that's the way it's going to be. It's going to eat into your time. But I'm going to make the test. I'm going to design the test so that it should be able to be completed within our class is 100 minutes, right? So I try and make the test where it can be done within 85 minutes. That's kind of the standard. I'm assuming we're going to take 15 minutes for you to print the exam or copy the exam. So just keep that in mind. And then once you receive the exam, I'll give you that time to print it or copy it. And then this is important. After you've got it printed or copied, okay, you're going to do three things. You're going to send me a chat in Zoom saying that, you're going to start the test. All right. So you say, okay, I'm done printing, whatever. I'm starting the test. I won't reply to you. Just go ahead and do that. And that's going to, let me know that what I see on your camera is you taking the test at that point. So then after you send me that chat, you're going to show the camera the front and back of every page you have in front of you. So the only thing you should have on your desk when you come on Monday is blank paper, all right? Blank pages so you can write your, do your work. And then when you print the test or copy the test, you'll have that. So you're going to show the camera all your blank pages in front of you, all right? And then you will begin to do the exam, and you will always be working on separate paper. So this is for the people who print the test. If you print it, don't go trying to do all the work on the printed test. That's not the way I designed it. It's all supposed to be done on separate paper. I don't want you to try and cram all this information, little tiny handwriting crammed and going up the side of the page. You understand what I'm saying? I want to see nice, clean work on separate paper. Okay, so you're working the test. Now, during the exam, you cannot have a computer screen on in front of you. All right, so you can't just be doing the work and reading the test off a computer screen. All right, that's not, everything's got to be like paper and pencil. So what I suggest you do is you have the Zoom app on your phone, all right, and set your phone up as your camera for the test. That's the way I suggest you do the test. Make sure you have a charger for your phone so your phone doesn't die in the middle of the test. And you may only have formulas that I provide, which I have not provided you any formulas for this test. There's really, let me think about that in a second. Right now, there's nothing I've provided for you. So that means anything that you need to know is going to have to come from, your memory. Now, during the test, you must have your camera on, right? And it must be placed in a position where I can see you in the entire work area, your entire exam, your desk area, and what's in front of you. Okay, so I'm going to be very strict about this. Do you see that? Everyone see that picture there? That's what I'm expecting. That means if you need to set your camera up off to the side, use your phone, I don't know, set it up on a chair or something. You're going to have to work this out between now and Monday. You're going to have to figure out how you're going to get your camera set up. I will not accept as an excuse on Monday, hey, I can't get my camera set up. I don't know what's, okay, you have time, all right? And you also, this is in the syllabus, you've known this since the very beginning. So I want this camera where I can see how you can see me, you can see my work area. Now, of course, that computer would have to be out of the way, but notice you can see what's in front of me, right? So I don't have like, I don't have like 30 pages of math notes taped up to the wall, right? You can see that I'm just, what's in front of me is just the papers in front of me. That's it. That's what I need. And it's just, I want a level, fair playing field for everyone in the class. Okay, that's what I'm trying to achieve here. It's very frustrating to have students who work really hard to learn the material and they do it this way. And then I've got a student who is, using their computer off on the side and, they have their camera set up where I can only see part of their head. And okay, so if that happens, you can't get your camera set up like this, then I'll boot you out of the test. All right, and you can't take the test. I won't accept anything. Are we clear on that? Any questions or concerns? Anybody right now feel like, oh, wait a minute, this can be a problem? When the test is starting, I will let everyone know, hey, Jose, your camera, you need to move it or something. I'll let you know if there's a problem with your setup, okay? And again, I have to be fair about this because y'all can see each other, right? So I've had students in the past tell me after a test, hey, I had my camera set up, but what about Dominic? Dominic didn't have his, it's not fair, So I have to be fair to everyone, all right? I don't want any student to be able to complain about something. So let's make sure you get that taken care of and you know how to do that before Monday. Okay, now, of course, I will be recording the exam, all right? So I'll be recording all your camera feeds. Once you finish the exam, you will then again send me a chat in Zoom, okay? You'll say, hey, I'm done, all right? I'm done with the test. I probably won't reply to you, all right? Just say, I'm done, and then you can leave, all right? You're gone at that point. All right, you can leave. Now, when you leave, you can shut your camera off and then you can use your phone to take pictures of your work and you're gonna condense, right? At that point, you're gonna condense all of your work into a single PDF file, okay? I'm worried about this, I'll be honest with you. There's 19 of you in the class. I put out an orientation video at the beginning of the semester, right? And at the end of the video, I asked you to try and do this, right? For those of you who actually watched the whole video, I said, let's try this and see if you know how to do this. Anybody want to guess how many out of 19 actually tried it? What do y'all think? 9. Okay, 9 of you did it. Okay. 2, 3, 4, 5, 6, 7. Oh, wait, 7 of you did it. I thought it was 9. Maybe it's more. I think these are the only people who did it. All right. So these people have already shown me they know what I'm talking about when I say condense, you know, all of multiple pages into a single file. So for those of you who did not do this, all right, and don't know how, or at least haven't demonstrated to me how to get into a single PDF file, that is the expectation for the test. You're going to have all your pages, you're going to take pictures, you're going to condense it into a single PDF, and you're going to upload that to me. I will send you a link on the day of the test. I will email the class a link to upload the test. If you send me 7 pictures, I won't accept it. It's got to be a single file. Okay. Are we clear on this? All right. So once you condense it, you'll send it to me using the link. I will email you in Canvas. I will give you 15 minutes to do this. So from when you send me that chat and you say, hey, I'm done with the test, the clock starts. And you have 15 minutes to figure out how to get all those pages condensed to a single file and uploaded to Canvas. If you know what you're doing, it shouldn't take you more than 5 minutes, 10 minutes tops. I'm letting you have 15 just as a little buffer in case. But what's going to happen is I'm going to, look at the test. I'm going to see what you submitted. I'm going to look at when you uploaded it, and I'm going to look at when you sent me the chat. And there has to be 15 minutes between those two. If it's 20, I won't accept it. All right. I know this sounds very harsh, okay, but I'm really serious about being fair, and I'm serious about maintaining the integrity of what we're doing here. All right. And I want to see what you know. So that's the expectation. If you fail to set up your camera properly during the exam, or you don't send me a single PDF file, then you'll receive a 0 on the exam. That's just me just making sure it's on paper what the expectation is. It's your responsibility to make sure that the file you send me has all of your work. I had a student in my Cal 2 class the other day. They sent me a file. I opened it up. It was a copy of the exam. Not their work, just a copy of the exam. That's what they submitted to me. It's your responsibility to make sure that the file you're sending me is your work, okay? If you miss any pages, I will not allow you to turn that work in late. Here's what I would say is the most important thing. After you take the test, you take pictures with your phone. Just make sure you keep those pictures, because if it really comes down to it, I would be able to go back and you'd be able to send me the picture files with the timestamps on them. Okay, so that, that's kind of like the fail safe. We have that just in case. So then I'll hand grade the test. And I'll post, what I'll do is I'll grade them, I'll write on them. I'll write on them like I do in class. I'll write on the actual document. And then when I post your grade, I'll upload the exam, my graded exam version to you. And so you'll be able to look at like what you missed and things like that. Questions?
Yeah, so you said we could take the formulas that you've given us, like could we use the quadratic formula and like other simple formulas that you've also given us already?
You know what I'll do? I'll do this. How about we agree to this? I will allow you to have one sheet front and back, okay, of formulas, steps, and procedures. You may not have any worked out problems, right? So you can't just take my review that I gave you with all the solutions worked out and say, oh, that's my reference sheet. No, it has to be formulas, steps, and procedures, all right? Front and back, 8.5 by 11 standard sheet of paper. You can handwrite it, you can type it, I don't care. And that covers that. That way, as you're going through the review, if there's something like, oh, I'm gonna need that formula, you can just jot it down and you kind of come up with a little reference sheet for yourself. Now, you will have to submit that though. Okay, you'll have to show it to the camera, and then you also have to submit it. Good question. See, you ask a question, you got something out of it. That's good. Anything else? Anybody concerned about the file thing I'm talking about? This is the PDF file. I'm being asked on the chat here, Can we use a scanner app like Cam's? Oh shit! I have a sticker on my jeans. Yeah, the Cam scanner is the one that most students use, right? Cam scanner. I think it's an iPhone app, and it allows you to, take pictures. I don't know. I don't have an iPhone, but somehow it allows you to take the pictures and then condense them down to a single PDF file. The problem is if you send me like a picture, right, a JPEG file or something, like iPhones have like a proprietary file type. So like it's hard for me to even open those sometimes. So single PDF just makes it easy for me. Any other questions?
We won't be able to use any type of calculator, right? It's just.
Oh yeah, you can use any calculator on the test.
Okay.
Yes.
Okay.
Yeah. Yeah.
And if we do, we'll be showing it to you along with the papers and everything that we're using for the test, right?
What, the calculator?
Yes.
Well, I don't really need to see the calculator. You just can't use your phone.
Got
Yeah, you can't use your phone as a calculator because I can't tell what you're really doing on it. And
Okay.
we all know, well, I don't know if you all know, but a lot of students know there's apps that you can get on your phone where you take a picture of a math problem and it'll freaking solve it for you. So, there's just no phones on tests. So you will be allowed to take a restroom break. If you need to get up and use the restroom, that's going to be fine. You don't need to ask, just go. Just don't go off camera for more than like 5 minutes. And if it's gonna be more than 5 minutes, you need to like send me a chat saying, hey, I'm not feeling well, something like that. Just don't disappear for more than 5 minutes and more than maybe once during the test. I don't think that you would need to disappear twice, but anything else? Okay, yeah, we're good. Okay. Yeah, I think then we can proceed. All right. We can proceed. We're going to talk about completing the square. Oh, and I gave y'all some problems last time, right? Didn't I? At the end of class, I gave you these to look at. So I wanted to just go through this last one because there was some confusion, and I'll be honest, I had a really bad day. The other day, my dog is dying, and it's been really stressful. And then he's dying, and then all of a sudden he's made a like miraculous recovery. I was like 2 hours from putting him to sleep, and and then he's like come back. It's been like a freaking roller coaster. So I was very distracted on Monday. But anyways, on this last type of problem where we have a negative in front of the X along with a number here, I think when I look back on that lecture, it was very confusing what I told you to do. So let's just run through that one. And in fact, when I posted the video for the lecture for that day, I just cut the whole end of it off because it was just so confusing. I didn't want that to be out there. So, all right, if we have a negative in front of X along with a number, right, then the process is a little different than all the others. What we do here is we first look at the -5 that's being subtracted from the X within the absolute value function. And that tells us that we are going to move the function left or right. And in this case, because it's -5, we're going to go to the right 5, opposite of what we think. So we go, let's see, to the right 5. 1, 2, 3, 4, 5. Okay. So this right here is the first thing I'm doing, and I'm going to the right 5. And it's the absolute value function, so I need to know it looks like a V. And then, oh, by the way, on your reference sheet, I do not think that it is fair to have all these essential functions like written and sketched. I would consider that to be not okay. So like you need to know what an absolute value function looks like. You need to know what a square root function looks like. So on your reference sheet, don't be drawing all the pictures of those. That you need to know. But if it's a matter of like you know, oh, okay, if you see, you know, you can write down, if you see a minus in there next to it, then move it to the right, that's fine, okay? So I moved to the right 5, and now I take care of this part, the second part. This negative in front means I'm going to reflect over what? What axis?
The y-axis?
Y. So I'm going to reflect over the Y. So it's kind of weird. The way I think you could do it is take that point right there at the bottom of the V and just reflect it over the Y-axis, and it puts it here, right at -5. And then every point does the same thing. So it's really kind of hard to see it, but the whole thing comes over the Y-axis and kind of lands back over here like this. And then the next thing is to do the 4 in front. That's the third thing. And this will be a vertical stretch. And so it's going to make this V look a lot more narrow, right? So it's going to make it go like this, stretching it up. And then the +7 is the last thing. This will be the fourth thing, and that would move that up 7. So just move the whole thing up, you know, 1, 2, 3, 4, 5, 6, 7, put a dot, very, very sharp V like that. All the others are pretty straightforward. It's really when you get that negative in there that you have to be careful and just do this first. Questions? Okay, let's talk about completing the square. So this is actually pretty cool what I'm about to do. This is the whole idea. Okay, the whole idea is, you know, if you have a linear equation, let's say we have a linear equation. So something like 4x minus 5 times x minus 3 equals, let's say, x plus 3. That's a linear equation, right? It's an equation that has x's in it. The highest power we see on x is 1. So it's linear. To solve a linear equation is relatively easy, because all you have to do, there's a set of steps, but all you have to do is get x by itself. That's it. Just get x by itself, move things around, multiply, like subtract, add, subtract on both sides, and you can eventually get your x to be equal to a number, right? And you work through it. That's fine. The problem that we run into is when we try and solve the quadratic equations. So when you have a quadratic equation, something like, let's say, x squared minus x minus 12 equals 0. If you're going to solve a quadratic equation, what you have to do is, well, there's a lot of ways to do it, but one way is, when you have a quadratic, is to move everything over to one side to get it equal to 0. That's usually the first step you do for a quadratic, get it equal to 0. And then you can try to factor this. All right, so you can try and factor this, and you get, I don't know, something like, in this case, x minus 4x plus 3 equals 0. So I'm assuming you kind of have seen that, know how to do that. You have some background with that. But what if we have something like this? So what if we have that? Can this factor? Can you break this down into two things equal to 0? Well, for those of you who know how to do this one, would this one work? Does this break down? Can I write this as x something, and make it a factor? The technique you're using here is you're trying to find two numbers that multiply to be -12, but add up to be this number. So can you think of two numbers that multiply to be -12 but add to be -2? I don't think so. What are the numbers that multiply to be -12? -1 and 12, or you could do 1 and -12. That's one possibility. You could do -2 and 6, or you could do 2 and -6. -3 and 4, you could go 3 and -4. All of these multiply to be -12, but none of them add up to be -2, right? If you take these two numbers, add them up, you get 11. These two, you get 4. These two, you get 1. These two, you get -11, -4, -1. Right? There's no way I can do this to make it work, right? So we would be stuck here. Does anyone know what you would use here, since this doesn't work?
Would it be an empty set?
Well, that would mean it has no solution, right? That would mean, but quadratics, we have this secret weapon, right? With quadratics that we can use. What is
The
it?
quadratic formula.
The quadratic formula, right? Y'all heard of that? Quadratic formula, right? Okay, so what I'm going to do is I'm actually going to show you a technique of solving this without the quadratic equation, but it's actually going to be what I used to prove to you the quadratic equation. So just hang tight. Let me just show you what I'm going to do. Okay, so right now we don't know how to break this down. So I'm going to do something right now with this called completing the square. I'm going to complete the square. All right, so let me rewrite the problem here. Now, what you need to understand about this completing the square is that this is a procedure that somebody came up with that works, okay? So when I'm doing it, don't be thinking so much about like, well, why are you doing that? You just need to understand like somebody has figured this out, all right? A human being sat here with this and said, you know what? Let me try this. Oh, let me try that. Let me try. And they finally came up with something that works, all right? So the first step for completing the square, all right? The first step is we are going to look at the number in front of the x term, okay? So find the coefficient of the x term. In that case, in this particular case, what I'm doing here is on the right side, I'm giving you the steps. Okay, and on the left side, I'm actually going to work the problem. So the first thing is I'm going to identify the coefficient on x, which means the number in front of x, which is -2. Okay, understand that? I'm just going to look at what's the number in front of x. It's -2. Now, the second step is we're going to divide that, okay, by 2. It's always 2. We will always divide by 2. Okay, so had this number here been an 8, we would divide it by 2. Well, if it was 11, we would divide it by 2. If it was -6, we would divide it by 2. Okay, so the second step is always to just take that number and divide it by 2. So I take -2, I divide by 2, and I get -1. I'm going to put a box around that. That I like to refer to that as the first magic number. It's not magic, okay? But that's the way I refer to it. It's our first magic number. You'll see what we do with it in a little while. The third step is we're going to square that answer. We're going to square that. So we're going to square what we just got. So the third step for us is to square this, which would be -1, square it, and that gives us +1. And that is our second magic number. All right. We good? We good? I know some of you have seen this, right? Let's do a poll. I'm curious to see how many have seen this because this next step is very important. Yes or no? Have y'all seen this, what I'm doing right now? Okay. Okay, good, good. All right, so that means like 65% of you have seen this, right? 65% of you have seen this. So since 65% of you have seen this, can somebody tell me what the next step is? Once you found that number, divide by 2, take it and then square it and get this number 1. What next?
You add it to both sides of the equation?
You add it to both sides of the equation, right? Okay, Diego, that's not wrong, okay? That's not wrong, but that's not the way I'm going to teach it to you. And there's a reason why, okay? And this is for all of you who are going to have to take Calculus 2. In Calculus 2, you have to complete the square within an expression, and it's not an equation. And so you don't have the ability to add a number to both sides because there isn't both sides. There's just an expression. So the way I teach it here is going to be able to be transported into Cal 2, and you won't have any problems. My Cal 2 students come in, they always want to complete the square and they want to add some number to both sides of an equation. And when they don't have an equation, they get stuck. Okay. So for everyone who's learned it that way, both sides of the equation, add this number, just erase that from your mind for right now. Here's what we're going to do instead. We're going to go back to the equation right now. Okay. And I'm going to realize, you are going to realize that next to that negative 2x, there is a plus 0. Okay. Then I still have minus 12. Now I realize that that seems weird. Okay. To say, oh yeah, there's a plus nothing here, but there is, right? There is a plus nothing. Agreed? Now I'm going to take this and I'm going to rewrite this 0 in a very weird way. I'm going to rewrite it by taking my second magic number, which was the positive 1. What I'm going to do is add that magic number and subtract the magic number. I'm adding and subtracting. So do you all agree that what's in red there is still 0? Yes? Okay. And then I still had the minus 12 equals 0. Notice that by doing this, notice that I don't even need this equals 0 here to do this. Like I could just be doing this, even if it was just an expression, I'm still working within the same side of everything. Does that make sense? Yeah. Okay, so what would be that fourth step? How do I describe that fourth step? I'm going to add and subtract the second magic number. And you do it after the x term. Okay, so right after that x term, the negative 2x, right after that, I added and subtracted the second magic number. By the way, for those of you who are maybe going to do a lot more math, what this step is really doing is we're basically realizing, oops. Golly, come on. Realizing a hidden 0, which is actually a very advanced idea in mathematics, to realize that next to everything is a plus 0. I think we are all comfortable with the idea that next to everything is a times 1, right? Like think about back in, when you're learning how to like add fractions, right? And you say, oh, okay, I need a common denominator. So what do? We multiply this one top and bottom by 5 over 5 and this one 3 over 3. Well, what you're realizing there is that next to everything is a 1, right? Being multiplied. There's always a 1 times next to it, right? Ooh, God, that's a terrible one. There's a 1 next to it. You've been doing that for years. Next to everything is a times 1. Okay, doesn't change it, it just looks different. Well, I'm telling you now that next to everything is a plus 0, and how you write that 0 can be many different ways. So, okay, let's continue. All right, by doing this, we're going to be able to do something, okay? These first 3 terms, okay? The first 3 terms guarantee factor as what we call a perfect square trinomial, which means that it's going to turn into, in parentheses, squared, something squared. It'll be x, and then it'll be just some number here squared, okay? Guaranteed, if you do this technique right. Now, the number that's going to be here is the first magic number. It's the first magic number. It's the minus 1. Now, do you believe that that's true? Do you believe that this turns into this? Well, how can we check it? Couldn't we just check it over here? Let's just check. If I take x minus 1 and square it, I have to do that. And then multiply through here, I get x squared. Here to here, I get minus x. Here to here, I get minus x. Here to here, I get plus 1. And then that becomes x squared minus 2x plus 1, which, yes, that is that, isn't it? Guaranteed, if you do completing this square correctly, that is guaranteed to happen, all right? Guaranteed to happen. Now, what do you still have remaining over here, though? What's still over here? Minus 1 minus 12, right? So now you have still here minus 13 equals 0. Okay. So what was that fifth step? The fifth step was the first three terms will factor as x and then, you know, something squared, and then that will be the first magic number. Okay. Here we go. We're going to continue. Now I'm just going to solve this. Watch how I do it. I'm going to add 13 to both sides. It's kind of funny. I'm going to be doing this today in my Cal 2 class. I'm going to be doing a problem where I have to complete the square, and the quadratic is going to be under square root, and we're not going to be able to do this, add this number to both sides, and like half my class is going to not know what to do. So it's kind of ironic that I'm covering both classes at the same time. Okay, so here we go. We added 13 both sides, and now what I'm doing is I'm going to take square root on both sides. And when I do that, the left side becomes x minus 1, and the right side, I have to do plus or minus because I did the square root. I do plus or minus square root of 13. And then the very last step is to add 1 to both sides. So I get 1, right? When I add 1 over here and add 1 over here, you get 1 plus or minus root 13. There are two solutions here, right? This represents two answers, 1 plus root 13 and 1 minus root 13. There we go. So back when I asked, and I said, how many of you know how to do this? And 65% of you said yes, and Diego said add 1 to both sides. Remember what I told Diego? I said, you're not wrong, okay? Because we have an equation. If you would have added 1 to both sides, it would have worked, okay? But moving along in your math life, you need to know how to do it when it's not an equation. So that's why I'm showing you this method, all right? Questions? All right. So there's something I forgot to put in the very beginning of this, step 0. So I'm gonna have to come up here and put the step 0 in here. Steps. Step 0. You must have 1 as coefficient on x squared. I forgot to say that. If we had, see out here, we have a 1 here in front of the x squared. See that 1? You must have a 1 in order to proceed with this method. If you don't have a 1, you've got to do something else. Okay, so I'm going to do another problem. All right, we've got the steps here. I'm going to copy the steps. I'm going to do a problem that doesn't have a 1. Okay. So let's do, and I'll be nice on this one still. I'll keep it relatively okay. Let's go 3x squared plus 14x minus 1. You know what? And I'm not going to make an equation out of it. I'm just going to ask you, well, yeah, I'll make an equation. We'll make an equation. There we go. So I want you to solve this. So right now, there's no way to factor this. Don't go waste your time. And you know what? Don't you, I'm telling you right now, quadratic formula is off the table. Okay, you're not allowed to use it. Okay, I want you to complete the square on this. So notice that there's a 3 in front, right? We can't have that. We can't, oh, you know what? I made a typo here. That 14, sorry, was supposed to be a 12. I was thinking in my mind what's going to happen next and put a 14 there. So that's 3x squared plus 12x minus 1. So step 0, you must have a 1 as a coefficient on x squared. I don't, I have a 3, right? So what I'm going to do is this. I'm going to pull a 3 out. Factor of 3. So when I pull 3 out of this, it just goes away and becomes x squared. When I pull 3 out of this, I get plus 4x. Now, you can't pull a 3 out of a 1, can you? Or can't you? Can you? You can. Watch. If I write this as minus 1/3, then it's correct. Think about what I just did, right? This was a 1. There's no 3 in here, right? But if I rewrite this as 1/3, think about what happens when I distribute this 3 back through, right? I get 3x squared, I get 12x, and then 3 times negative 1/3 would give me the negative 1. So even though it's weird, it is allowed. I can do that. You'll follow me? Okay, what I want you to do now is focus all of your attention on the blue. Kind of forget the 3 for now. All right. I want you to just look at the blue here, and I want you to follow these steps and see if you can get to step 5. Just see if you can get to step 5 with the blue part in here on your own. And then let me know if you get to the end of it. I'm going to relaunch the poll. Just let me know when you're done with the first 5 steps. If you have a question, please feel free to just unmute yourself and ask. while y'all are working on it, I'm going to start working it out silently. About 7 of you are done already. We'll just go 30 more seconds. Okay. So from the work I've done here, does anyone have any questions? Stop it.
How did you
Sorry.
get the 13/3?
Yeah, okay, so let's go through this. I took the 4, I took half of it, and then I squared, I got 4. That's my second magic number. There's my first one. So then I took this expression right after the 4x, I added and subtracted my second magic number. And then these first 3 are guaranteed to factor as x plus 2. There's the first magic number squared. And then I did -4 minus 1/3. So over here, let me make sure I did this right. This, I'm doing -4, take away 1/3. So I need a common denominator. -12/3 minus 1/3, which gives me -13/3. That clear?
Yes, sir.
Okay. And notice that when I was doing this, the whole time I was doing it, that 3 that I pulled out, I just left it. Like I put all this in that red parentheses, and that 3 is just sitting out there, right? Just sitting out there. I'm going to go ahead and distribute the 3 back through. So I'm going to multiply it here and here. So when I multiply it times the first piece, I get 3 and then x squared plus 2 squared. 3 and then x plus 2 squared. And then minus, when I hit this 3 with the 13/3, the 3's cancel, I get 13 and then equals 0. And now I'm just going to continue with my algebra. I'm going to move the 13 to the other side. So add 13 to both sides. I'm going to divide both sides by 3, trying to get this squared piece by itself. Now I'm going to take the square root on both sides, plus or minus. I get x plus 2 equals plus or minus the square root of 13/3. And then I have to subtract 2. So I get x equals -2 plus or minus the square root of 13/3. There are my 2 solutions. Questions? No questions? All right. So you sure? No questions. I'm going to move on. So why would we do all that, right? Why would we do all that if we have this? We know, I know most of you know this, that if we have any quadratic equation, right? Give me any quadratic. right? That we can get the solutions to this, right? The solutions by using the quadratic formula. Which we learn is the solutions are x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a, right? Why would I go through all this trouble that I just did if I had this formula? The formula works, right? The same, I mean, it'll give me the answers just like what we just did will give me the answers. This one will work as well, and it's just probably faster. Let's see. If I take that problem that we just had, right? Ah, come on. Why isn't it not letting me? Stop. Okay. If I take 3x squared plus 12x plus 1 equals 0, right? That's what we had. Oh, minus 1. Minus 1 equals 0. If I want to solve this quadratic equation, I can use this formula. I just need to identify that a is 3, b is 12, and c is negative 1, right? And then just plug it into this formula. Let's try it. If I go and use the formula, I get x equals, okay, negative b. Well, b for us is 12, so negative b would be the opposite of that, which is negative 12, plus or minus the square root. And now I have b squared, that's 12 squared, it's 144, minus 4 times a is 3, so 4 times 3, times c, which is negative 1, and then all divided by 2 times a, but a was 3. You have seen this, yes? Quadratic formula, you have seen this used, right? Okay, this would become negative 12 plus or minus square root of 144, take away, let's see, we're actually gonna take away a negative number, so we're gonna add 12 here. And that's over 6, so this gives us negative 12 plus or minus the square root, let's see, 144 plus 12 is what, 156, I believe? Over 6. And I believe we can break down 156. Let me get my calculator. 156, I believe, is, yeah, hold on. What is 156? $156 can be broken down to be 4 times 39, right? Can I go further? Let's see, hold on a second. Make sure I got this all right. Negative b plus minus. So 150. Let's see, let's look at what was our answer. Our answer looked different, didn't it? This was our answer. Okay, yeah, that's right. The 3 is on the answer. Let me bring that over here. Or do we have the same answers here? They look different, don't they? Don't they look different? Let me convince you these are the same. Okay, I'm going to stop on this one right here. I'm not going to simplify it anymore. What I'm going to do is this. I'm going to try and convince you these are both the same. What I'm going to do is I'm going to take this plus or minus. I'm going to do this root 13 over root 3 like that. I'm going to multiply the top and bottom by root 3 over here. That's rationalizing the denominator. So you get negative 2 plus or minus, let's see, if I do root 13 times root 3, you can put those together to become root 39. You just multiply what's underneath the roots. And then root 3 times root 3, that will give you 3 on the bottom. And now if I get a common denominator between these two, I have to turn the 2 over 1. I have to multiply it by 3 over 3. And so I get negative 6 plus or minus the square root of 39 over 3. And that's this answer. Okay, let me just do something up here. All I'm gonna do here is rewrite this as plus or minus 2 root 39. So I'm using the fact here that 156 breaks down to be 4 times 39. And so I can do the 4 underneath this root and pull it out as a 2 in front of the root. And then if I reduce this by 2, that by 2, and that by 2, sorry, 6, we get the same answer, -6 plus or minus root 39 over 3. So look, all I'm trying to do here is convince you that what we did with completing the square gives you the same answer as what you get when you do the quadratic formula, right? That you get the same result. So why do the completing of the square if we have the quadratic formula, right? Why do that? Well, really the main reason is like I just mentioned for Cal 2. We want to be able to complete it the square on an expression. When we have an equation, yeah, use quadratic formula, okay? Use it because it's faster, all right? Y'all okay with that? All right, I want to do one more thing. This is going to be the last fun thing on this. This will be fun. I think you'll enjoy this. Maybe not. Some of you will. All right, here's what I want you to do. I want you to complete the square. Let me go get those steps. I would like for you to take this generic quadratic equation. See, it's generic, ax squared plus bx plus c. I'm not giving you numbers here, just a, b, and c. I'd like for you to complete the square on it. All right, so what's the first step? You have to have a 1 out front, don't you? In front of the x squared. Do we have a 1? We have a, right? So we can't have an a. So I need to factor an a out. Watch me factor the a. Pull the a out. I will have the x squared here. And then if I pull an a out from the b, it would have to turn into b over a in front of x. And then if I pull an a out from the c, I'm going to have a c over a equals 0. Do y'all believe that? All right, if I push this a back through, I'll get ax squared. Great. The a times b over ax, the a's will cancel. I have bx. When I push the a through here, the a's will cancel. I get c. Yes? So that's a legal move? Yes? Alyssa, you okay? Do you know where I'm going with this, Alyssa? Okay, it's fine.
One moment, sir. Sorry.
Okay, it's okay. Does anyone know where I'm going with this? Do you know, does anyone have an idea what this is going to lead us to?
The quadratic formula?
The quadratic formula. This is exactly where the quadratic formula comes from. All right. So I think that's why it's cool to see it. So I'm doing the same procedure. Let's just keep going. I pulled the a out. Okay, now the next step is to find the coefficient of the x term. The coefficient of the x term is the thing out in front of the x, right? I'm going to take that and I'm going to take half of it, right? So I'm going to take b over a and divide it by 2. That's terrible. And divide it by 2. That's the same as taking b over a and multiplying. What's the reciprocal of 2? What's the reciprocal?
A half.
A half. So dividing by 2 is the same as multiplying by a half, which is b over 2a. Okay, that's my first magic number. The next step is going to be to square that, right? So now what I'm going to do is I'm going to take the b over 2a and I'm going to square it, which gives me b squared on top and on the bottom 4a squared. So I'm just squaring the top one, squaring the bottom. 2a times 2a is 4a squared. Now I'm going to add and subtract that second magic number. This is my second magic number. I'm going to add it and subtract it right after the x term. Here it comes. So we have a, we have x squared plus we had b over ax. I'm going to add that second magic number and subtract that second magic number. And I still had next to it the plus c over a equals 0. Y'all see I'm following the same procedure, right? It's just I've got letters instead of numbers. Okay, now the next thing is that I know for sure the way this will work, this will guaranteed factor to be something squared, and it'll be the x, and then right here will be the first magic number, right? First magic number, which is b over 2a. So I'm going to put plus b over 2a. And then I still have all this crap out here, right? I still have the minus b squared over 4a squared plus c over a. Y'all good? I know it's messy, but I mean, this is it, right? The next step I'm going to do, I have choices here. Let me put these two together. Let me just squash those together. I'll do it over here on the side. I have minus b squared over 4a squared, and then I have plus c over a. If I put those together, I need a common denominator, which has to be 4a squared. So I'm going to multiply the bottom by 4a over here and the top by 4a over here. Does that seem fair? Do it that way? Okay, so now the bottoms will both have 4a squared. Let's see what my numerator is. It's minus b squared plus c times 4a. I'm going to write that as 4ac. Are y'all starting to see pieces of the quadratic looking like they're appearing here? Right? All over 4a squared. That's those two together. So here's where I am now. A x plus b over 2a and then squared. And then I have, notice this fraction, let me write it. Yeah, I'll keep it this way, but notice that negative is up on top here. This division bar comes all the way, so that negative is not out front. So the way I'm going to write this is like this. I'm going to write plus negative b squared over 4 plus 4ac all over 4a squared equals 0. I'm going to distribute the a through to both of these. So when I do the distribution, the a goes in front of this one. And then plus, when I multiply this whole thing by a, right? Imagine there's an a right here. It would cancel one of those a's out on the bottom. And so I'd still have negative b squared plus 4ac all over 4a. That's all I'd have is 4a now, equals 0. We're getting close. I'm going to move all of this to the other side. So I get a x plus b over 2a squared equals negative, because it went to the other side, negative b squared plus 4ac over, we just have 4a on the bottom now. Y'all still following this? Next thing I'm going to do, this negative sign out front, I'm going to push it through the top as a -1. So it's going to turn that positive and that negative. So I get b squared minus 4ac all over 4a. Next thing I'm going to do is divide both sides by a to kill that a off. So when I divide this side by a, I get another a here on the bottom, which will get me back to an a squared. Oh, I thought I was out of room. So now I have x plus b over a 2a squared equals b squared minus 4ac over 4a squared. Finally, I can take the square root on both sides. Plus or minus. So on the left, I get x plus b over 2a equals, and over here, because I'm doing a square root, I can do the square root on the top and the square root on the bottom separately. So when I do the square on the top, I get plus or minus square root of b squared minus 4ac. And on the bottom, when you take the square root of 4a squared, the square root of 4 is 2, and the square root of a squared is a. Now, the plus or minus can be on the top or the bottom. I'm just going to leave it there on the top. I'm now going to subtract b over 2a from both sides. And when I do that, I'm almost there. X equals, I have the minus b over 2a that I just subtracted on both sides. I have the plus or minus square root b squared minus 4ac all over 2a. And since these two things have the same denominator, we can put them together. And when we put them together, we get our quadratic formula. Okay. So that's where it comes from. All right. It's not some magical thing, right? It's the completing the square technique done on a general quadratic. And if you do that, you wind up with the formula that we use, right? The formula that you've been taught. Now you know where it comes from. Pretty cool, huh? If you've never seen that, right? I would never ask you to derive that, okay? I would never ask you to derive that, but this always reminds me when I do this. This always reminds me that there's a difference between knowing something and understanding something. All right. So, like, you may know the quadratic formula, great. All right, but do you understand where it comes from? Right. That's two different ideas. So, like, I always think about, like, if I was stranded on a desert island, right, and I forgot the quadratic formula, well, then I'd be screwed, right? But I understand where it comes from. So as long as I know how to do the completing of the square, I could always generate that formula myself. That's two different ideas. One is memorization and the other one is understanding. And as you move and progress through your academic career, whether it be computer science or, you know, biology, whatever it is that your major is, right? You want to get to a point where you're understanding things as opposed to just knowing it. There's two different things. All right, while we're talking about this, this is called a cubic equation. You'll see that that's different from a quadratic. The highest power of x is 3, but it's a general equation with the highest power being 3. That's called the cubic equation. And then you could have a fourth degree equation like this: ax to the fourth plus bx cubed plus cx squared plus dx plus, let's say, e equals 0. That would be a fourth degree equation. So we have a formula for a quadratic, right? If we have a quadratic, we have a formula. Yes? And we just proved where it came from. What do y'all think? Do you think that there's a formula for a cubic? Do y'all think that there's a formula for this? Just like a quadratic formula? What do you think? Yes? Yeah, there is. You want to see it? Let's look it up. Let's look up the cubic equation formula. Oh, I've searched it before. All right, let me see. There it is. Okay. Yes. This is the reason you probably weren't sure if it existed, because it's a disaster mess, isn't it? A mess. I mean, that's a lot different than than the quadratic equation, isn't it? There was a point in my life where I had to work this out at some point, and it's not fun, but well, it actually was fun. But wow, what an equation, right? If you know what A, B, C, and D are, the solutions will be all of this stuff, okay? All of this stuff. What about fourth degree? Do you think there's a fourth degree polynomial equation? I wonder if that page had it. Let's see. Did they have it fourth degree? I don't see it there. Let me try it. Fourth degree. I got to be able to type properly. Polynomial equation formula. Quartic function. We'll go to Wikipedia, even though that's not necessarily a good thing. Yeah, let me go to images. I think we'll get it with an image, maybe. No. Yeah, here we go. Yeah, it has something to do with this. So it's a mess, okay? It's a mess. And actually, this is if you have a 1 on the 4. This one. Yeah, you just have to believe me that it's much worse than this one. You believe that, right? I mean, you would think it would, right? Here's the amazing thing, though, all right? The amazing thing here is that once you get to 5th degree, right? If I did a 5th degree polynomial, there is no equation. All right. 5th, 6th, 7th, 8th, there's no equation. And when I say that, I don't say it in the sense of we have not been able to find it. Okay. That's not what I'm saying. I'm not saying we've never been able to discover the 5th degree equation. We've actually been able to prove that it does not exist, that it can never exist. So we only have formulas up through the first 4, and that's it. After that, no equations exist, which is pretty weird, I think. It's strange. Okay, all right. So if today seems like I'm kind of like taking my time and not throwing too much crazy stuff, it's because I really don't want to overload you for the test, because this isn't going to be on the exam. I may put a bonus question though. I might put a bonus question where I ask you to complete the square or something. So, all right, we good? So at the end of the day, if you see a quadratic equation, okay, if you're ever doing quadratic equation, trying to solve it, I always recommend you try and factor it first, because factoring is super fast if you're good at it. If factoring doesn't work, I recommend you go to the quadratic formula. All right. That's if you're solving a quadratic equation. Now, if you're in like in a Cal 2 class and you're trying to do something with a quadratic and it's not an equation, well, then you're going to have to complete the square. So you need to know how to do that process. All right. Now let's really get into the 4-3. We don't have a ton of time left, but we have enough time to kind of like frame out what we're going to be doing. So our goal here is to look at quadratic functions. So a quadratic function is any quadratic or any function that looks like this. Ax squared plus bx plus c. All right. So this is a function. This is not an equation. All right. This is just a function. And the thing we want to know about this is, what do these look like? We know what linear functions look like, right? We already know that if you give me a function like this, mx plus b, we know that's linear. And we know that when we graph it, we're going to get a line, right? That we know, right? But this quadratic function is going to look different, and we need to know what it looks like, and we need to be able to graph these. So I'm sure that a lot of you know what these look like. What are these called when we graph them? The graph is what do we call it?
Parabola?
Parabola, right? The graph is what we call a parabola. It's not a straight line, right? So when it comes to a quadratic function, they're either going to look one of two, they're going to look like one of two things. It's either going to be a parabola that does this, or it's going to be a parabola that does this. Now the shape may vary. It may be very narrow or maybe very wide, but they're all going to look like a U that's either like up or down. And there's an easy way to determine which of these two it is. The easy way is to just look at the number in front of x squared. That number right there, a, whatever that number is dictates whether or not you have a parabola that goes up or down. So this will happen if a is positive. This will happen if a is negative. So we're going to get more into this, but I wanted to discuss before we get too far, I want to discuss where parabolas are important, like in the real world. Like, where do we use them? Like, why is it important at all to study parabolas? Like, why have humans needed to study parabolas? So can anyone think of where they've ever seen a parabola in the real world? No? Have any of you ever, oh, go ahead, Henry.
I was gonna say maybe like a bridge or something.
A bridge has a slight curve to it. It could be parabolic. It could be. It could be. You've all thrown a ball, right? Everyone here has thrown a ball, right? I hope, right? If you throw something through the air, right? Next time you have the opportunity, even sitting there, you throw a pin across the room or something. If this were a classroom, I would actually ask one of you to stand up on the front of the room. We'd start throwing something back and forth to each other. And when you throw something through the air, it travels through this arc, right? There's this curve. Well, that has to be a parabola. It will always be a parabola. So as soon as you throw something and let it go and start letting it go through the air, that shape, there has to be some quadratic function that would model the path of that object through the air. Now, why is that important? Well, what has always been one of the big motivations, or what is it about humans that has accelerated science and technology more than anything else? Where do we usually have huge leaps in technology? When we're doing what? Where did like nuclear energy come from? What were we trying to do? We're trying to kill one another, right?
I was about to say, wasn't it energy or killing each
Yeah,
other?
I mean, it was war, right? War always pushes technology, right? Our need to the human need to not get along has always pushed technology, right? The internet, why was the internet created? Y'all know why the internet was created? No? Okay, good, I'll tell you. So this is the United States of America. It's terrible, but it's the United States of America, all right? And, nuclear, during the Cold War with the former Soviet Union, we had all these nuclear weapons pointed at each other. And it was just, we were just waiting for someone to blink, right? And back then, all of our nuclear missiles had control centers, in different parts of the country is where we controlled our nuclear weapons. So the fear was that if there was a strike against us, you could take out these control centers and then we could never launch counterattack, right? So we needed a way to communicate. We needed a communication grid that couldn't be wiped out easily, right? That it was a network that even if you knock out one section of it, the rest of it's still interconnected and said web, right? So the internet was like, we'll use the phone lines, right? The phone lines we've got everywhere, right? It's like this huge spider web connecting us all together. So even if you take out one little node of it, there's still a bunch around it. And that's why the internet grew. It was to decentralize our communication system. But now you can't undo it now, right? It's there. You can't take it away. So again, technology is always pushed by conflict. Human conflict always pushes it. So when you think about a parabola, I have to take you even further back in history than nuclear weapons. But I mean, just think about, everyone loves those shows, right? Those, I don't know, was it Game of Thrones? I didn't really watch it, but you know, just think about, you have a castle. Here's a castle. I know it's impressive, right? And you want to start launching shit into this castle, right? And you want to make sure that these people submit to you, right? Open up the doors and give you all their gold and, you know, turn them into slaves, whatever. So you're trying to get in there, and you can just like randomly be throwing shit into the castle, or you can understand that this is a function, right? That there's some parabola that governs how that's going to travel through the air. And then you can start predicting where you're going to put things, right? So instead of, you know, accidentally going too far, too short, or into the wall, you're trying to take out a certain, you know, tower or something, you can actually put that on target, right? But you have to understand the mathematics behind it. Now, maybe back in the medieval ages, they didn't have this technology, but I'm just saying back then it was almost like just lob it and hope for the best. Now, what can we do? Right? We can drop it. We can drop something from almost space and put it on a, you know, a 2 foot by 2 foot target, right? Anywhere, pretty much anywhere in the world. Okay, now that's a different technology. It's not a problem, but the idea again is, you know, the more you know mathematically about the path of the projectile, then the more accurate you become. In modern day artillery still uses mathematics to calculate where they're going to put where they're going to put their munitions downrange, but it's all done by the computer, right? The computer does all the calculations, but the mathematics is still just parabolas. That's all it is. Okay, so that's one thing. Okay, any other ideas where a parabola can be used? Something not so morbid as war. How about a flashlight? Your headlights on your car. All right. So think about a flashlight. Have y'all ever seen or noticed that on a flashlight, maybe you have that flashlight that has, you know, you have your beam coming out like this, and at the end of the flashlight, you can turn the end of it and it changes what the beam does. Yes, you've seen that? So what's happening there? Well, inside here, there's a light bulb, right? Here's a little light bulb, and it's putting out light in every direction, right? Light's coming out in every direction around that bulb. Well, behind the bulb is a parabolic mirror. It's actually three-dimensional, but it looks like a parabola behind it. And these light rays hit the mirror and reflect out. 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 And if you put that light bulb in the perfect position, right? If you position that light bulb perfectly, all those light beams will reflect out straight. And you get a very narrow directed beam of light. Now, when you turn the end of the flashlight, what happens is you move the bulb. Sometimes you move the mirror, sometimes you move the bulb, depends on the way it's designed. But when you move, let's say, the mirror backwards, now the beams hit the lens or hit the mirror in a different way, and they come out a little bit off angle, right? And so now what you're doing is you're spreading those light rays out. And so you get a wider beam of light. It's not as intense, it's not as bright, but it's wider. But you have to have a parabolic mirror in the back. It can't be a half circle. A half circle is not a parabola. And so if you use a half circle, you will never get the beam effect. You have to be parabolic to get the beam. Only a parabola will do that. So your headlights, right? When you do your low beams, they're more like when you're just driving, normal driving, that's more of like a spread out light. And when you put your high beams on, it turns on brighter lights with a parabolic aims, aimed where it's forcing that beam straight out. And you get really bright, intense light very far down the road. Okay, that's another example. Cell phones, right? We use cell phones. So how do cell phones work? I mean, just generally speaking, right now, again, I apologize. Today is a very just chill day. We're not doing a lot of math today. It's really more about just let's get ready for the test, but let's talk about quadratic functions because they're important. So when I'm sitting here, right, and you're sitting over there, if I call you right now, right, if I just dial your number and call you, you're going to almost instantaneously, you're going to get that call, right? So what's happening? Well, I'm sending out a signal from my phone, right? It's being sent out all around. It's being sent in every direction, going through the walls, going through the windows, right? And somewhere around me is a tower, right? And up on that tower, there are these, they look like these, like this, like little rectangular boxes up here. And inside those boxes are parabolic receivers. They're parabolas in there. And what they're doing is the reverse of what the headlight beam did. It's sitting here and it has what's called a receiver here, like a little satellite. And it's basically listening meaning it's just pointed out there. And it's getting my little signal that's coming out, my signal's coming out from my phone, right? And these signals are hitting that. A couple of them are hitting like this, and they're all getting reflected back. And when they get reflected right back to that little point right there. They all reflect in and go to that little point. That point actually has a name, it's called the focus. All parabolas have what's called a focus, which is a point that all the beams get reflected to. And so that tower says, oh, okay, it's receiving basically a bunch of ones and zeros and it knows what to do. We're not going to get into the computer part of it. It hears it by getting that reflection, takes that, and then it pretty much amplifies that and sends that out, okay, to another tower. Sometimes it goes underground if they're connected through, wires underground, but if they're not connected, then it just sends it out again. And it might go through like 8 towers and then finally get to the person I'm calling, which is just freaking amazing, right? Just that's all happening with everyone's phones, and it's all like sorting all our phone calls and texts, and it's sorting all that out. It's amazing. But you don't have a parabola, you can't collect it. You can't hear if you don't have a parabola. And so then you get the call. All right, great. Well, what about if you want to take a person and make a call to the other side of the world? So now you can't have towers because you have oceans between you, right? So what we do is we have our tower here, right? And now I'm making a call and the network knows I can't go through towers to get to this person, right? So what it does instead is this tower sends it up to a satellite that's sitting up here in space. And that satellite is a big parabola, just listening, right? Pointed out there, just listening. And it's going to collect that, reflect it to the focus, right? And then there's another satellite over here. It's going to send that information to that satellite, and then to the next satellite, and then to the ground over here to a tower, and then that gets sent out to the phone. So it's like piggyback through the tower, through satellite, back down to the ground, and it all happens like, within a couple of milliseconds. It's crazy. So parabolas are important, I'd say, yes. All right, so it's important for us to study them. So what we are going to study, we're only going to study in this class, right, at least right now, parabolas that open up or down. Okay, we can study parabolas that open sideways, but we're up and down. If we understand this, then everything else sideways is pretty much the same. We just switch letters around. All right, so given some function that is parabolic, A dictates our up and down. Let's talk about some other things on a parabola. Let's talk about x-intercepts. If I ask you right now to draw me a parabola, right? You get to draw any parabola, it can be up or down, doesn't matter. How many x-intercepts can you have? What do y'all think? So Javier's saying 2. Okay, it's possible to have 2. I agree, it is possible to have 2. If I draw this parabola, I'm going to have 2. Is it possible to have 3? If you draw a parabola, can you ever hit the x-axis more than twice? No, right? There's no way. No way you can do it. Now, can you hit it once? Yeah, if you draw it just right, let me draw a different parabola. You draw a parabola just right, where it just comes down and touches just like that, then that would have 1, right? 1 x-intercept. So we said we can't have 3, we can't have 4, can't have 5. So anything 3 and higher, we can't have. We can either have 2 x-intercepts, we can have 1 x-intercept. Is it possible to have none? Yeah, if you draw it correctly, if you just, let's say you draw it, let's make it open up. If I draw this parabola, right, I'm never going to hit the x-axis. Or I could have one that opens down and looks like that, and I would never hit the x-axis. So with x-intercepts, when it comes to x-intercepts, we can have 0, 1, or 2. Those are the only possibilities, right? 0, 1, or 2. And it just depends on the parabola itself. Okay, let's talk about y-intercepts. What do y'all think? If I draw any parabola, Henry's saying 1, we'd have 1 y-intercept. Are we guaranteed 1? Are we always going to have 1 and only 1? Is there any way to draw a parabola where we have like anything other than 1? I mean, go crazy here. Draw as many as you want, however you want. Doesn't matter how you draw it. Any parabola you draw, you're only going to hit 1 time, the y-axis. Only once. There's no way to avoid it either. It has to happen. Even if you try and draw a parabola way over here to the right, say, oh, that doesn't hit the y-axis. Well, it keeps spreading out, and eventually, right, eventually it will. There's no way to avoid the y-axis. And there's no way to get more than 1. Right? Because if you had more than 1, wouldn't it not be a function? Wouldn't it fail the vertical line test? Right? Like if you said, oh yeah, you have 2, well, then you don't have a function. Okay, so with y-intercepts, always 1. Always 1. So x-intercepts, you could have none, you could have 1, or you could have 2. Y-intercepts, you have to have 1. Let's talk about a couple of other aspects. This will be the last thing we do. If I draw a parabola, let me just draw a vertical one, or one that opens up for now. On this, you can see we have our x-intercepts here. You can see we have our y-intercept here. Those are important points on this parabola. But there's one other point on a parabola, this point right here. That is called the vertex of the parabola. And the vertex is either the lowest or the highest point. Right, depending on if it opens up or down, right? If it opens up, this will be the lowest point, right? If the parabola opens down, like this, then the vertex would be the highest. Right? So it just depends. If it opens up, you're going to have a lowest point. If it opens down, you're going to have a highest. And one of the things that we're going to need to be able to determine is what that is. Like if somebody gives us a parabola, can we find that highest and lowest point? And we'll be able to do it. There will be a formula I give you, and that will allow us to get that point. Okay, let's just call it a day. We've got like 4 minutes left. I want to have some time if anyone has questions over the test. We'll hit parabolas, next week, a week from today. We'll really get into graphing these, and you don't have any homework due for 4-3 at all right now. So yeah, that's it. So you're free to go. See you on Monday. If not, if you have questions, hang out and I will answer questions.
Thank you, Professor.
Have a good weekend.
Have a good one.
Thank you, Professor. Have a good one.
You as well.
Hey, Professor, I have a question about last night's homework.
Yes.
One of the problems for the gas bill part, I'm just trying to figure out how to get the second function.
Yeah. That's a tricky one. Okay, so hold on. Let me get to it. You're talking about the 3, 4 or 3, 5? 3,
I
5.
think it was 3.5.
Yeah, hold on. Give me just a second. Assignments. Okay. Was it the last one? Let me see.
I think it was the second to last, or the last one.
Wait a minute. Did
I
open
think
the
it was
wrong one?
3.4 because I had the same question and it's the last two questions. I was like kind of confused.
3, 4. Yeah, okay. Practice. Okay, this one or the one before, you said the gas bill one?
Yeah, I had a question for the gas one. It was the develop a function that models the monthly charge. I had one of the functions, but I couldn't get the other one.
Okay, so let me copy this first. This is actually a really good problem because it's more like something you would see in your real life, right? So,
Mhm.
all right, so let me make this a little smaller here. Okay. All right, in March 2014, a gas company had the rate schedule shown to the right for natural gas usage in single family residence. Okay, what is the charge for using 40? Develop a function. What's the charge for using 250? Okay, so let's just make sense out of this. First of all, you have your service charge, never changes, always 21.45 all the time, right? Okay, then you have a delivery charge for the first 50 therms, whatever a therm is, measurement of energy, right?
Mhm.
So for the first 50 therms, let's highlight these in a certain color. When we're talking about the first 50, we're going to be paying that much per therm. And then the natural cost, the gas cost itself is for the first 50 therms is this. So the way I guess we could look at this is this. Let's do our cost function. Let's say cost, and I'm going to put T here for therms. It's going, let's talk about what's happening. It's a piecewise function. You'll see why in a minute. As long as the therms we have are less than or equal to 50, then it's going to be 0.74956 T plus 0.3221 T. And then, oh, I'm forgetting the
monthly
fixed
charge.
cost. Yeah, plus the 21.45. So do y'all both agree with that part?
Yes, sir.
Okay. Now, if T is bigger than 50, right? If T is bigger than 50, then we're going to pay this much. Let me highlight that one in blue. We're not going to pay anything, right, for the delivery anymore, but we're going to pay this much for each therm, right?
Mhm.
Each therm past 50. Okay, past 50. So what we need to do first is this. We need to assume if T was 50, let's say T was 60, right? We first have to pay for the first 50, right? Which means you have to plug 50 into this and see what you get.
Mhm.
Right? Plug 50 in. Let me do it real quick.
You could also combine those two.
Yeah.
Okay.
What does it come out to be? I
It's
guess.
like, well, I want to say like point or 1 point something.
Yeah.
Give me a
Yeah,
second.
you could combine because they have the same variable there. So if T was 50, okay, if T was 50, what I'm getting there is 53, 58 about, that's these two together.
Mhm.
And then I have the 21.45, right? you understand what I'm doing?
Yes, sir.
Okay. So if I get to anything over 50, well, first of all, I have to pay for all this, right? Which comes out to be 75, like 033 or something like that.
Mhm.
Okay, that's like my new fixed cost. Plus, I've got to pay this much per therm for the rest of it, right?
Yes, sir.
So if you put 0.5637 T, it won't work. Why doesn't that work? Because if you put T here, if T, let's say T is 60, then you're going to take this and multiply by 60, aren't you?
Mhm.
But you're not paying this much for 60, you're only paying this much for 10 because the first 50 are accounted for in here. So you have to put here T minus 60. I'm sorry, minus 50. So
Okay.
think about that for a minute. If T is 60, think about if T is 60,
Mhm.
right? We're going to use this function. This piece right here will basically cover the first 50 we paid for.
Mhm.
If I plug 60 in right here, 60 take away 50 is 10. I'm only going to pay for 10 therms at that rate. Yeah, that makes sense.
Yes, sir.
And then like you can imagine if you had like 3 tiers, right? For the first 50 and then maybe for like 50 to 100 and then maybe 100 to 200, right? You have like 3 different tiers of pricing, then it gets really complicated. But that I think is the key to that second formula is this right here. You good?
Yes, sir.
Alyssa, that good? Okay. Now, I don't know what the answer is. It would, let me see if it shows us the answer.
And the answer I had to like shorten it out or like simplify it. Because I tried doing that for my answer, but it wasn't saying it was correct.
Why isn't it giving me? Trying to get it to give me their answer, but this is a different problem, so it's not. I was just curious to see how it would. Oh, geez. There we go. Yeah, so they combine them together. Now, these are different numbers, right?
Yes, sir.
So this right here, what we would maybe still need to do here is, I don't know if you did this, distribute this through.
Oh, okay.
And if you do that, you'll get 0.5637 T.
And
And then when you do that times -50, you'll be able to combine it together with that.
Okay.
Get a number.
I see where I went wrong now.
So 0.5637 times -50. That's 75.033. Yeah, so I think it would come out to like this plus 46.848. That's what I would get here.
Okay.
Let me see. Yeah. That makes sense though. I mean, let's not let the pickiness of the computer like cause an issue here. As long as you understand the concept, that's more important.
Okay, I got it.
Yeah.
Yes, sir.
Okay.
Thank you so much, sir.
No problem. Anything
Have a good
else?
day.
Oh, you as well.
Thank you.
Thank you. Question? No? Ashley? Ashley?